Hi, today we're going to study chapter 14, uh, atmosphere and hydrosphere. Section 1, we're going to discuss regions of atmosphere. Atmosphere is the basically all the gases around Earth's surface, and the hydrosphere is the water surround Earth's surface. Uh, the ocean, river, lake, swimming pool, together covered 75% of Earth's surface. 75%. So now, what do we have in air, in atmosphere? Uh, Near the ground, if it's dry air, you're going to find 78% of nitrogen and 21% of oxygen. So these two occupied 99%. Number one, nitrogen. Number two, oxygen. Everything else together, only 1%. Okay, so now next one, we're going to discuss a little detail about the atmosphere. Atmosphere is about 600 kilometer, start from the surface of Earth up. Okay, so it's roughly about 400 miles. So now we're going to see how the pressure change. When you go higher and higher, you see the pressure decrease. So the vertical axis is the altitude from sea level, and horizontal one we use for pressure. And here we use a new pressure unit, bar. Okay, so 1 bar equals 100 kilopascal. We studied this one before. The 1 pascal equals 1 Newton per meter square. So 1 bar equals 100 kilopascal. And also we use the millibar. That's 1,000 bar equals 100 pascal. This kilopascal. So now, if we use bar, then the normal pressure we call atmospheric pressure at sea level when temperature equals 20 degrees is exactly 1 bar. Okay, so now you say that's 1 bar. That's 1,000 millibar. 1 bar. Okay, so now the pressure will decrease when the altitude increase. Pressure decrease. At the top of the atmosphere, pressure will equal 0. Okay, so here is the highest mountain on Earth, about 9 kilometer or 6 mile. Okay, see top of mountain of this mountain, the pressure decrease to about 1/3. So that's 1,000. That's a little over 300. Okay, so pressure decrease. Okay, so now how about the temperature? So we're going to study a little detail about the 4 regions of atmosphere. Remember there are 4 regions, 4 of them. Okay, and we are going to study their name. Okay, and some basic property of different region. Okay, from bottom, first one called troposphere. Troposphere. Let's make a little bigger. Okay, troposphere. And second one called stratosphere. Stratosphere. The third one, mesosphere. And last one, thermosphere. So that's 4 region. Be careful the height. So the first one is only from 0 to 11 kilometer, and the second one is from 11 to 50. So see, this is about 10 kilometer, and that is 40. Then from 50 to 80, that's a 30. It looks like the same because when we study it, we had to make about the same size, and we cannot make too much different. So now, especially the last one, the thermosphere, start from 80 up to 600. Okay, see, this is 10, this about 40, this about 30, and this is more than 500, more than 500 kilometer. So you need to keep that in mind. Okay, now, so about the four region, we should know their name, their order. Okay, so the first one called what? Second one called what? Start from sea level. So now this is the altitude. Okay, the horizontally we use this as the temperature axis. Okay, we choose middle 0 degree Celsius, and then temperature be increase. That's 50. That's 100. So 0 to left, that's negative 50, negative 100. So now the first region, troposphere. Okay, again from 0 to 11 kilometer, the temperature decrease. Means you go higher and higher, temperature drop until to the top. The temperature is about 55 degree negative. That's negative 50 degree. Here, negative 55 degree. So why temperature decrease? Because the Earth warm up the atmosphere. The energy of atmosphere comes from the Earth's surface, not from the sunlight directly. We're going to discuss later. And near the Earth's surface, we have many molecules. We call the greenhouse molecules. Greenhouse molecules, like carbon dioxide and water vapors. These molecules are very special. The sunlight can check in, then energy received mostly by the Earth's surface, land or water. Okay, then the Earth gave the energy back as heat, infrared. So light can check in, the heat cannot check out. So now we call the greenhouse effect. We're going to discuss more detail. So now later, these molecules, greenhouse molecules, give energy back to atmosphere. So because the atmosphere warm up by Earth's surface, so that's why close to the land, close to the surface, the temperature higher. Then you go higher and higher, you have less and less molecules, temperature drop. Now, because temperature decrease, drop in first region of the troposphere, so now the warm air goes up because of lower density. Then temperature drop. So the gases, the water vapors, condense, become liquid. So that's cloud, right? Cloud. Many water droplet. So later, when this water droplet moving around, collide each other, stick together, become bigger and bigger, then the air cannot hold them anymore. They're going to drop. That's the reason rain, or snow, or even tornadoes. Okay, so in first region, the weather conditions very unstable. Now, the second region we call stratosphere. So that's S-T-R-A-T-O, sphere. So from 11 up to 50 kilometer. So now in second region, temperature increase again. from about 15 degree, from negative 55 degree back to 15 degree, from negative 55 back to 15 degree, positive. So why the temperature increase again? Because another special molecules we call ozones. The oxygen molecules mostly is the O2, two atom combined, and ozone is three atoms combined. So that's O3. So this ozone very small amount, okay, but they're very powerful because these molecules, the ozone molecules, can trap, absorb the ultraviolet from the sun radiation. The sun solar energy, not only visible light, also ultraviolet. And this energy trapped by the ozone molecules. So that's why temperature increase. So now inside the region, okay, the weather conditions were stable. Why? Because the bottom, look just this region, the bottom is cold, lower temperature, and top is hot. Okay, so now the warm air keep on the top, and the cold air stay at the bottom. Not like first one, the warm air goes up, cold air goes down. We call convection. The air go up and down. Second one, the air just stay the way it is. The cold air at the bottom, warm air, okay, on the top. So it's very stable. You don't have air go up and down. So the weather condition is very good. No many not much cloud, no rain, no tornadoes. So that's why airplane always fly higher, okay, above the first region. The airplane most time fly in stratosphere because it's safe. Okay, now the third one we call mesosphere. Let me make it a little bigger again. Okay, so third one, mesosphere. This is from the 50 kilometer up to 80. So now the temperature drop again from 15 degree positive to 75 degree negative. So drop again. Why temperature drop again? Because there are not many air molecules, no greenhouse molecules, no ozone molecules. The density of the atmosphere dropped to 1,000th of sea level. Okay, simply speaking, suppose you have a box, let's say 1 centimeter cube, 1 cubic centimeter. So the box in the first region, you're going to find 1,000 molecules inside. But same box come to here, you're going to find only one, just for the example. So that's why I say the density dropped to 1,000th of sea level. Okay, so it's pretty much empty. So that's the third one. So now the last one we call the thermosphere. Okay, remember this is a big one, from about 80 all the way to 600 kilometer. Above that is the vacuum, we call outer space. Okay, so now what happened to temperature here? Well, increase again. So this temperature will increase from about negative 75 degree up to, can be as high as, we don't have space there, up as high as 2,000 degree. So 2,000 degrees seems very, very high. But when we say 2,000 degree here, we only mean the molecules go very, very fast. Remember the temperature and kinetic energy of molecules are related. higher temperature means more kinetic energy, or means molecules move very fast. So there are not many molecules, but they're moving very, very fast. Why? Because they absorb energy from the uh, the uh, the sun radiation, ultraviolet. But this one, that one's a little different. In the second region, stratosphere, this ultraviolet a frequency is lower, and this frequency is much higher. Higher frequency means what? More energy. Remember, energy equals a constant time frequency. Okay, so now because the molecules in the last regions, the thermosphere, observe the energy, very high energy, so these molecules move very, very fast. Move very, very fast. So because these molecules move so fast, they collide each other, then some are going to catch electrons, become negative ion, and some lose electron, become positive ion. Okay, so now here's the information about the four regions. Let me go back a little bit. Okay, so I give you more detail you can read. So remember the name and order. The first one, the troposphere and the stratosphere, mesosphere, and last one we call thermosphere. And some basic properties like basic properties. I will not ask you to remember all these special numbers. So now we can discuss a little more about the last region, the thermosphere. Okay, this from 80 all the way to 600 kilometer. The temperature increase, and the reason we discussed because of the ultraviolet, okay, from the sun, and discuss how high is temperature. And when you have time, you can read more detail. So now ionar sphere. This is the inside of the thermosphere. Okay, so remember we say the molecules in the last region become what? Become ions. Means some lose electron, some catch electrons. And even more, see the solar wind. So that's the particles, the charged particles from the sun, travel all the way, take 9 minutes, come to us, come to the Earth. So now this, what is solar wind? What's inside? Well, mostly the protons and the electrons. Okay, so now remember we have a magnetic field of the Earth. And here's the Earth. The magnetic field extends long, far away. Okay, so now when these particles from the sun enter magnetic field, what happens? The magnetic field is going to change the direction of those particles. We discussed that in chapter 6. Okay, so now this particle is going to run this area, because near the North Pole or South Pole, the magnetic field are stronger. Okay, then these particles interact with the charged nitrogen and oxygen in atmosphere. So they collide each other, interact each other. So they're going to lose electron and catch electrons. Remember what happens when electrons go up and down to different energy level. We studied in chapter 9. They're going to give off the light, right? This is hydrogen, and this is neon. Okay, I don't have oxygen and nitrogen here, but anyway, so they're going to these particles, these molecules, Okay, mostly the nitrogen and oxygen. Okay, going to lose electrons, catch electrons, then give off all different color of light because energy change. So that's the reason of what auroras. Auroras. We also call northern light. And here's the two pictures. Were beautiful. It's all because of the ions, the charged molecules. Lose electron, catch electron, then give you all kind of color. Different color, different frequency, different energy. So that's the reason. So now, next section we discuss the water in atmosphere, and we discuss humidity, which is indicate the water vapors in the air. The whole world is powered by sun, the solar energy. So the water body, like ocean, receives the solar energy. Then molecules goes up, evaporate. Then condensation, you have cloud. Can you see that clear? Cloud. Okay, so that's water molecules. Okay, so now the wind blow the cloud from place to place. So that's why the solar energy carry the water power to place, to the land, to the mountain area, desert, come to Arkansas. So that's because solar energy. Okay, so now when air hold the maximum amount of water vapor cannot hold anymore, we call saturated air, saturation. When we watch the weather channel, okay, so they give us the relative humidity. They will say 100%, 50%, or 75%. So this you should remember. So what is definition of relative humidity? That's a percentage that indicate the degree of saturation. 100% means the air cannot hold anymore. That's the maximum. 50% means 50% of saturation. Okay, so remember the relative humidity is a percentage that indicates the degree of saturation of the air. So now how much moisture the water vapors the air can hold depends on the temperature. When temperature increase, okay, then the air can hold more. Say I give you some number here. At 10 degree, air can hold up to 10 gram per cubic meter. 20 degree, 20 gram per cubic meter. But not linear. When 30 degree can hold up to 35. So you all have the experience in home. So, well, in the spring season, like this season, if you take a shower and you don't turn the heater on, what happens? You're gonna see many water, okay, moisture on the mirror in the bathroom because temperature is low. So now, if you turn on the heater, when temperature increase, you're gonna see this disappeared because now when temperature increase, the air can hold more and more water. That's the reason. Section 3, clouds. Okay, we can discuss the different okay fogs. Is the large volume of air contact the land or water and then condense to liquid. So the fogs and clouds same thing. One is close to the Earth's surface because the cold overnight. So the air condense to the water vapor. So that's the fog. So now if they goes up because convection, so warm air goes up to high sky, then condensed, that's cloud. So warm air rises, expands, cools down, and then condensation, condensed to liquid. Okay, cloud covers about half of the Earth's surface. Okay, so now when the inside the cloud, the water droplet, there are too many of them, going to moving around, collect each other, then stick together. So the water droplet become bigger and bigger. The water droplet become bigger until reach about 2 millimeter average. So now this droplet become too heavy. So air cannot hold them anymore. So going to drop. So that's the reason we have rainfall. That's rain. Okay, so now the rain because the air is warm. Okay, so the warm air here. So maybe start with the ice crystal or water droplet, but fall all the way to the ground. That's the water, the rain. That's rain. Okay, now if the air is cold, say all the way below 0 degree Celsius, or 30 degrees Fahrenheit. Okay, so it's going to be ice crystal drop all the way, so that is snow. And sometimes air is warm, but the land is very cold. So you have to start with the water droplet all the way to ground, then freeze. We call freezing rain. That's very very nasty. So sometimes we even need to cancel school because the road is the very bad condition as ice. And sometimes the air, the high air, high atmosphere is warm, so the water droplet. Then near ground, the temperature drop. So then halfway freeze. That's called sleet. So that's a different the rain, freezing rain, and sleet and snow. How that happens. So you already see a lot in daily life. Okay, so now let's see the last one. Hail. That's HAL. What happened to here is because of very bad weather. Very stormy weather, the cloud like this. Okay, so now, so you see the clouds go up and down, rotate, twisting each other, very complicated. So now the water droplet will go high and low, high, low, make many loops before drop to the ground. Now see what happened to this one. So now suppose here's the line we call freezing level. Okay, so water going to freeze, goes up and back, melt down. So we call freeze and thaw. Okay, so it goes up, freeze, comes down, melt down, then pick more water, droplet, then goes up again, freeze again, become bigger, ice ball, then goes down, pick more water, and up again, many times before fall all the way down. So that's why the ice ball falls down. We call hail. So now a few important the weather terms. Meteorology that study weather and weather pattern. And the weather usually we mean at a given time, the short period of time. So the temperature humidity, air pressure, and rainfall at any given time. So we say the weather today, weather tomorrow, maybe next Monday. Now climate is for the long term, long period of time. So that's for season or for years. So the summary of the weather condition over long period of time, period of season and years. So that's few definitions. Okay, so next we're going to discuss the energy in atmosphere. So first, every object will emit or give off the radiations we call EM waves. Remember radio wave, microwave, visible light, X-ray. However, the intensity and the peak of wavelengths depends on the temperature. Let me tell you what I mean. So if object has high temperature, they will give very high frequency. For example, this one's about the object temperature equals 4,000 degrees. You will see the violet color mostly. So now if temperature drop to 3,000, you're going to see blue in the peak. 2,000, you see the green. So now, what about the sun? The sun, the surface temperature of the sun is about 6,000 degrees. And inside is like a million degrees. But surface is about 6,000, 5,700 degrees. So now at this temperature, you're going to see all the color come out. So the white light. So the sun radiate visible light. I choose different color. Okay, so different color combined give you a white light. So what about the Earth? The Earth also radiate, but because the Earth's temperature is only 15 degrees, so Earth radiate the heat, or we call infrared light. It's the heat, invisible, invisible. Okay, so what kind of radiation depend on the temperature? The sun give visible light, and the Earth gave the infrared or the heat. Okay, now the solar energy comes to the Earth. We call incoming solar radiation. That is the solar energy enter the atmosphere. And also we call insolation. So please remember, insolation, insolation, that is incoming solar radiation, okay, to the atmosphere. So now about 30% of insolation just go back to the space. So the atmosphere, this is the land, this is top. So that's about 600 kilometers. So the behavior of the atmosphere is just like a mirror. So some radiation just go back to space again. So now the most part enter the atmosphere and mostly receive observed by the land and water. So Earth's surface receive most energy. Okay, only small part, roughly 20%, observed by atmosphere directly, like ozone molecules. So remember, most energy from the sun, most insolations received, observed by Earth first. Then later, the Earth gave back the energy to the atmosphere. Gave energy back to atmosphere. So the reason is because the greenhouse molecules, the light can check in, the heat cannot check out. So the heat trapped in the atmosphere. So this is very important. Otherwise, the daytime going to be too hot, and nighttime become too cold. If the greenhouse molecules cannot keep the heat in atmosphere. So now Okay, so I want you to remember the conclusion. It's very important. That's called the greenhouse effect. The most sunlight pass through the atmosphere and observed by Earth's surface. Okay, then later Earth radiate, give off the infrared or the heat, which mostly trapped by greenhouse molecules. So the conclusion is the atmosphere warmed up by the Earth, not by sunlight directly. Let's read again. The atmosphere warmed up by the Earth, not direct sunlight. So this diagram gives you what happens. The sunlight received by the land first, then later radiate heat, and these molecules, this carbon dioxide, trap the heat, then later give back to the atmosphere. So the time delay. The Earth receive energy first, then later give back to atmosphere. Okay, so that's why the 2 o'clock afternoon, 2 o'clock afternoon usually is warmer than 12 o'clock. Well, the 12 o'clock is the time the Earth receives more energy, but 2 o'clock is the time when the Earth gave energy back to the atmosphere, most energy back to the. So that's why 2 o'clock is warmer than 12 o'clock, because greenhouse effect. So now for the yearly, annually, so why the July and August warmer than the June? Okay, so annually, the June is time Earth receive most energy because sunlight goes straight to the Earth's surface, not from this angle, more straight like this way. More energy come, more solar energy come to the June, but the Earth warm up first, then July and August is the time when the Earth gave most energy back. So that's why there's time delay again, because greenhouse effect. So that's why July and August are warmer than June. Okay, then here's the applications we just call greenhouse, right? So okay, different season, especially like winter time. Okay, you can plant some vegetables like cucumber, tomatoes, and flower inside of greenhouse. And you see that's covered by glass or plastic. So the sunlight can check in, okay, but heat cannot check out. Okay, so that's why you can keep the inside warm. Okay, it's a greenhouse effect. The sunlight can check in, the heat cannot check out, just like that. Another example, like inside your car, the summertime. So if you open the door, inside so hot, so hot. Okay, hotter, warmer, temperature higher than outside. Why? Because your glass, the window, the glass of the car, the light can check in, but heat cannot check out. So that's the reason. Okay, so we're going to stop here for today. Thank you.